Singapore, a densely populated global city, faces high land demand due to its economic importance and future needs, leading to ongoing land reclamation from the sea. East Coast Park, spanning 185 hectares on reclaimed land with a 15-kilometer coastline, is Singapore's most visited park, attracting 7.5 million visitors annually. Its strategic location near the seaport, Singapore Strait, and Changi Airport makes it a vital sea-city interface. It is a key part of Singapore's City in the Garden project. In recent years, flood has become a major problem for the city-state, costing significant loss every year. With about 30% of its land below 5 meters above the sea level, it is prone to coastal and urban flooding. This is particularly true for the East Coast area, where high tides and heavy rain often causes flooding, affecting lives and critical infrastructure during monsoon rain and flash flood. Urban flooding results from heavy rainfall, poor drainage system and clogging, while coastal flooding may happen due to storm surges, king tides and sea level rise. Singapore faces a serious threat from rising sea levels with projection of up to 1 meter by 2100, compared to global estimates of 0.26 to 0.82 meters. Despite its small size, Singapore's high carbon dioxide emission density contributes significantly to global warming and sea level rise. Addressing this involves costly strategies such as raising land levels and building sea walls. Singapore faces a growing concern with the urban heat island effect, which significantly raises temperature up to 6 degrees Celsius in its city center compared to the surrounding areas. It leads to a 12 to 24% rise in residential cooling demand. By 2030, it will increase Singapore's energy demand up to 40%. The Concept Plan 2001 anticipated land requirements for a population of 5.5 million by 2050 at 800 square kilometers, necessitating additional land allocation for residential use, industrial purposes, new green spaces, and transport infrastructure. To overcome land scarcity, Singapore has embarked on land reclamation since the 19th century, expanding its territory by 24%. Additional land reclamation has adverse effect on human and natural environment. It increases water temperature and turbidity, decreases oxygen levels that harms coral reefs, fisheries, and causes algae problems. It damages blue carbon ecosystem and destroys mangroves. Biodiversity can be reduced by 30 to 70% in affected areas. Sand dredging and construction process emits carbon dioxide significantly. Also, sand mining contributes to estuary erosion, riverbank collapse, and loss of mangroves. Now we welcome you to the Bluescape Loop, a biointegrated floating city, a new urban living with blue carbon circularity and regeneration. Let's break down the words Bluescape Loop. Blue means water-sensitive design, includes new wetland, new floating archipelagos. Scape denotes regeneration of nature and implementing nature-based solution to combat challenges like floods and sea level rise, transforming it into a regional carbon hub. Loop says us to embrace a circular economy, converting waste to resources, creating a zero-energy, carbon-negative city. Now understand our design strategies. In this section, we will see our design proposals that helps to mitigate existing flooding problems, adapt to future sea level rise problems, and regenerate a new regional carbon sink in a nature-based solution. In Phase 1, inspired by beavers, we introduce a natural elevated protective system made with semi-permeable modules. In Phase 2, a new wetland along East Coast Park is designed. In Phase 3, a new mangrove layer is added as the first layer of defense. In Phase 4, mangrove forest will grow naturally over the years. Beaver Dam will use gravity to drain excess water during heavy rain and flash flood, also protects against sea level rise. The semi-permeable layer will allow one-way direction of water flow from the wetland to the sea. Wetland will work as a buffer space and reservoir that increases city's water catchment capacity. By widening water channels and converting areas into marshy land to slow surface runoff, features like detention, retention, greeneries, and rain gardens will be installed. These combinedly work to manage floods in different conditions like heavy rainfall, flash flood, storm water, urban flooding, tidal surge, and sea level rise. Different types of new activities and installation is integrated here that will boost regenerative tourism. In this section, we will see our design proposals that is adaptable to sea level rise, regenerate new water-sensitive urban life to mitigate Singapore's future needs. Considering the adverse effects of traditional land reclamation process, we opted for a water-sensitive floating city concept. In Phase 1, we identified Singapore's major transportation networks. It will integrate MRT, expressways, airport and water transportation to establish multimodal connectivity. In Phase 2, we identified major urban anchor points or gravity points along the East Coast Park, surrounding which the city will be grown. In Phase 3, we identified major urban nodes to connect urban amenities and movement networks. In Phase 4, we stimulate urban growth within a radial zone of 15 minutes cycling distance and create a 15 minutes neighborhood. The people of the city can reach any mode of transportation and their desired activities within 1.2 km radius distance. In Phase 5, we propose self-sustaining 5 minutes walking communities. Each cluster is attributed with functions like recreation, residence, mixed use, or agricultural use. In Phase 6, all these communities will form a cluster of supporting activities over the years based on their future demand. A protective natural buffer will be grown with the city following edge conditions like tidal wave directions, airflow directions, sea level depth, etc. This city, designed with prefabricated modular structures, acts like a living organism. Based on dynamic future demand, this module's position will be reconsidered. There will be addition of modules if demand increases, subtraction of modules if any specific function or modules or its ecosystem does not properly work. Based on the unknown future conditions, the module form can be modified or, for the most optimum functionality, to adapt to various edge conditions, these modules can be reorganized spatially. This city will grow in a demand-based bottom-up approach. We call the process morphogenesis, a natural growth system. City will have data center in every neighborhood that will continuously collect data on weather, climate, geography, natural calamities, ecology, population growth, and demand data. All this data center collectively works as the city brain. Based on different significant events, this central system will give us necessary data to initiate city growth. All this data will be put in a simulation system. It will give us all the optimum data. Based on the simulation, the city brain will tell us to add, remove, relocate or rearrange modules. The size and precise location of the particular modules can be told by this system. This process will be supported by robotics, AI, GPS system that is already prevailing in Singapore. Following the real-time data, deep learning, we can replicate this growth pattern anywhere of the Singapore or any coastal region of the world. Arterial routes align with Singapore's dominant seasonal airflow direction, creating a wind corridor that increases wind speed by 30% compared to the kinked alignments. This corridor, combined with gradually decreasing building heights, produces wind downwash effects, reducing urban heat island effects and lowering temperature by 2 to 4 degrees Celsius. As a part of the circular economy, all the waste is reused to increase their lifetime, recycled and transformed into resource and energy. It reduced material and energy demands and waste generation. We are proposing modular prefabricated architecture that can be assembled or dismantled quickly based on their future condition. Recycled materials will be used to reduce their carbon footprint and new materials will be synthesized from waste ash and water sludge. We are also generating new opportunity for aquatic farming and agrotourism. That's how it becomes a zero waste, zero energy, carbon negative, regenerative water sensitive city. Thank you.